Hello everyone, welcome to this video. In this video we are going to solve today Cambridge International AS and A-Level Paper 1 Pure Mathematics 1 May-June 2023 9709/12. The first question is the equation of a curve is such that dy by dx equal to 4 over x minus 3 the whole cube for x greater than 3. The curve passes through the point 4, 5. Find the equation of a curve. To find the equation of the curve, first we need to integrate the given dy by dx. Let's write dy by dx as 4 multiplied by x minus 3 the whole power negative 3. Now integrate on both the sides, so you will get y is equal to 4. We can take out the constant. So integral x minus 3 the whole power negative 3 dx. Write the constant 4. X minus 3 the whole power. Increase the power by 1. So negative 2 divided by the new power, that is negative 2. Coefficient of x, which is 1, plus c. So y is equal to negative 2 multiplied by x minus 3 the whole power negative 2 plus c. Now substitute the point 4, 5 because the curve passes through the point 4, 5. It will satisfy the equation. So 5 is equal to negative 2 4 minus 3 the whole power negative 2 plus c. So c is equal to 5 plus 2, which is equal to 7. So the equation of the curve is y is equal to negative 2 divided by x minus 3 the whole square plus 7. Next, question number 2. The coefficient of x power 4 in the expansion of x plus a the whole power 6 is p, and the coefficient of x square in the expansion of ax plus 3 the whole power 4 is q. It is given that p plus q is equal to 276. Find the possible values of the constant a. So the coefficient of x power 4 in this expansion. To find that, first let's write the general term. This is the binomial expansion question. So the general term is 6c r x power r a power 6 minus r. So here we need the coefficient of x power 4. So we can take the r value as 4. So the coefficient of x power 4 is 6c4a square, which is nothing but 15a square. and coefficient of x power 4 is marked as p. So p is equal to 15a square. Next we need to find the coefficient of x square in the expansion of ax plus 3 the whole power 4. So the general term will be 4cr ax power r 3 power 4 minus r. So to get the x square coefficient, we have to take the r value as 2. Four C2 a power 2 3 power 4 minus 2, which is 2. So this is marked as Q. So Q is equal to 4C2, which is nothing but 6a square multiplied by 3 square, that is 9. $54a square, that is our Q. So it is given P plus Q is equal to 276. $15a square plus 54a square equal to 276. 69a square equal to 276. So a square equal to 276 divided by 69, which is equal to 4. So a is equal to plus or minus 2. So the possible values of a are plus 2 and minus 2. The next question is question number 3. Express 4x square minus 24x plus p in the form a multiplied by x plus b the whole square plus c, where a and b are integers and c is to be given in terms of the constant p. To write the given expression in the completed square format, first let's take out 4 commonly. So x square minus 6x plus p. Now to make this as perfect square, we need to add and subtract 6 divided by 2, that is 3. So x minus 3 the whole square minus 3 square plus p. 4x minus 3 the whole square minus 4 multiplied by 3 square. So the value of a is, by comparing here and here, it is 4. B is equal to this, so negative 3. And C is equal to negative 36 plus P. Hence or otherwise, find the set of values of P for which the equation 4x square minus 12x plus P equal to 0 has no real root. It has no real root, that means B square minus 4AC is less than 0. What is b value? B values 4 multiplied by 4 multiplied by p. This is less than 0. So 5, 7, 6. Minus 16p is less than 0. Thirty-six is less than p. Next question number 4. Solve the equation 8x power 6 plus 215 x cube minus 27 equal to 0. To solve this question, let's use the substitution. So t is equal to x cube. Okay. So 8t square plus 215t minus 27 equal to 0. So what is t? T is equal to minus 215 plus or minus square root of 215 the whole square minus 4. A is 8. C is negative 27 divided by 2a. A value is 8. On simplification, we get t is equal to 1 over 8 comma negative 27. So substitute t is equal to 1 over 8. So t is nothing but x cube. X cube is equal to 1 over 8. So x equal to 1 over 2. Similarly, t is equal to minus 27. X cube equal to negative 27. X equal to negative 3. Question number 5. The diagram shows the curve with equation y is equal to 10x power 1 over 2 minus 5 over 2 x power 3 over 2 for x greater than 0. The curve meets the x-axis at the point 0, 0 and 4, 0. Find the area of the shaded region. The area of the curve is integral a to b y dx. So the limit here is from 0 to 4. The y value is 10x power 1 over 2 minus 5 over 2 multiplied by x power 3 over 2 multiplied by dx. Now let's integrate this one. 10x, increase the power of x by 1, so 3 over 2 divided by 3 over 2. minus 5 over 2 multiplied by x power, increase the power by 1, so 5 over 2 divided by 5 over 2, 0 to 4. Let's apply the upper limit. These two gets cancelled and this is equal to 20 over 3 multiplied by 4 power 3 over 2 minus x. X is 4. 4 power 5 over 2 minus 0. So this is equal to 20 divided by 3 multiplied by 8 minus 32. On simplification, we get this as 160 minus 160 divided by 3 minus 32. 160 minus 96 divided by 3, which is equal to 64 divided by 3. So the area of the shattered region is 64 divided by 3. Next, question number 6. The diagram shows a sector OAB of a circle with center O. Angle AOB is equal to theta radians and OP is equal to AP, which is equal to x. Show that the length AB is 2x theta cos theta. So we need to find the arc length. So the arc length formula is r theta. So we need to find r value as well as the theta value. And this triangle OPA is an isosceles triangle. So the two sides are equal. So these two angles will be same. So this is also equal to theta. And this will be then pi minus 2 theta. So now we know the angle is pi minus 2 theta and we need to find OA. Okay. So to find OA, let's draw a perpendicular line from P to the line OA. When you draw a perpendicular from this corner in an isosceles triangle, then this will be the midpoint. It will meet at the midpoint. So OM will be is equal to MA. So this will be of OA. Okay. Now consider the triangle OPM. In this triangle, cos theta is equal to the adjacent side, which is of OA divided by the hypotenuse, which is x. So in triangle OPM, cos theta is equal to of OA divided by hypotenuse is x. Okay. So from this we can write OA is equal to 2x cos theta. So the arc length AB is equal to r theta. So r is 2x cos theta multiplied by theta. which is equal to 2x theta cos theta. The next part of the question is, find the area of the shaded region APB in terms of x and theta. We can calculate the area of the shaded region by calculating the area of the sector minus the area of the triangle. Of r square is OA value, that is 2x cos theta square multiplied by theta minus area of the triangle is of AB sin theta of the side of the triangle is 2x cos theta. Another side of the triangle is x multiplied by sin theta. So this is equal to 2x square cos square theta multiplied by theta. So I'll write it here. 2 theta x square cos square theta minus x square cos theta sin theta. We can take out x square cos theta commonly. We get 2 theta cos theta minus sin theta. This is the area of the shaded region. Next, question number 7. By first expanding cos theta plus sin theta the whole square, find the three solutions of the equation cos theta plus sin theta the whole square equal to 1. So first we need to expand this. This is of the form a plus b the whole square. So a square plus 2ab plus b square. So cos square theta plus 2 cos theta sin theta plus sin square theta equal to 1. Or we can write this as cos square theta plus sin square theta is 1. So 1 plus 2 cos theta sin theta minus 1 equal to 0. We can write this as 2 cos theta sin theta equal to 0. That means cos theta equal to 0 or sin theta equal to 0. Cos theta will be equal to 0 within this domain when theta is equal to pi over 2. Sin theta will be 0 when theta is 0 as well as pi. So theta is equal to 0, pi by 2, comma pi are the solutions. So the next part of the question is, hence verify that the only solutions of the equation cos theta plus sin theta equal to 1 for 0 less than or equal to theta less than or equal to pi are 0 and 1 over 2 pi. So here it is given cos theta plus sin theta equal to 1, and for this we need to verify. Only these two are the solutions. Okay. So let's verify that. When theta is equal to 0, cos 0 plus sin 0 will be equal to 1 plus 0, which is equal to 1. So this is correct. And let's verify 1 over 2 pi. So cos pi over 2 plus sine pi over 2 equal to 0 plus 1, which is equal to 1. And this is also verified. Let's take another value for theta. Now this time we will take pi. So cos pi plus sine pi equal to, cos pi is equal to -1, sine pi is 0, so we get -1. So this is not true. So we verified theta equal to 0 and theta is equal to 1 over 2 pi are the solutions, are the only solution. The next part of the question is prove the identity sin theta divided by cos theta plus sin theta plus 1 minus cos theta divided by cos theta minus sin theta is equal to cos theta plus sin theta minus 1 divided by 1 minus 2 sin square theta. So to prove this, first let's consider the left hand side of the expression and take the common denominator. The common denominator is cos theta plus sin theta multiplied by cos theta minus sin theta. In the numerator, sin theta multiplied by cos theta minus sin theta plus 1 minus cos theta multiplied by cos theta plus sin theta. In the denominator, we have cos theta plus sin theta multiplied by cos theta minus sin theta. This is of the form a plus b multiplied by a minus b, which is equal to a square minus b square. So, cos square theta minus sin square theta. So, expand the brackets in the numerator. Sin theta cos theta minus sin square theta plus cos theta minus cos square theta plus sin theta minus sin theta cos theta. Now we can cancel these two terms. We can write the remaining terms as cos theta plus sin theta minus sin square theta minus cos square theta. So minus of sin square theta plus cos square theta divided by cos square theta minus sin square theta. But in the denominator, the answer we need the expression in terms of sin only. So for cos square theta, we will substitute cos square theta equal to 1 minus sin square theta minus sin square theta equal to cos theta plus sin theta, and this is equal to 1. So negative 1 divided by 1 minus 2 sine square theta. Hence we proved this one. Next part of the question is using the results of A, 2 and B, solve the equation. So what is the result of A of 2? So it says that cos theta plus sin theta equal to 1 has only two solutions. Okay. Then B part, it is given this is equal to cos theta plus sin theta minus 1 divided by 1 minus 2 sine square theta. Okay. From this part, we will write this left hand side expression as cos theta plus sin theta minus 1 divided by 1 minus 2 sine square theta. And this expression is equal to 2 multiplied by cos theta plus sin theta minus 1. Cos theta plus sin theta minus 1 is equal to 2 times 1 minus 2 sine square theta multiplied by cos theta plus sin theta minus 1. Let's take all the term into one side. Cos theta plus sin theta minus 1 minus 2 times 1 minus 2 sine square theta multiplied by cos theta plus sin theta minus 1 equal to 0. So from these two terms, take cos theta plus sin theta minus 1 commonly. So we get 1 minus 2 times 1 minus 2 sine square theta, which is equal to 0. So cos theta plus sin theta minus 1 multiplied by 1 minus 2. So negative 1 plus 4 sine square theta equal to 0. So we can write this as cos theta plus sin theta minus 1 equal to 0, or 4 sine square theta minus 1 equal to 0. So for this part, we know already the solution. Theta is equal to 0, pi over 2. Sine square theta is equal to 1 over 4. Or we can say sine theta is equal to plus or minus 1 over 2. So theta is equal to sine inverse of plus or minus 1 over 2. So theta is equal to pi over 6. And the next value is pi minus pi over 6. So that is 5 pi over 6. So theta is equal to 0 pi over 6 pi over 2 5 pi over 6. These are the solutions. Next, question number 9. The diagram shows the graph of y is equal to f of x, where the function f is defined by f of x equal to 3 plus 2 sine multiplied by 1 over 4x. On the diagram, sketch the graph of y is equal to f inverse of x. So to sketch the f inverse function, first we need to draw the mirror line, that is y is equal to x. So this is the mirror line, y is equal to x. Next, let us mark the point. So this will come here. So we need to reflect the curve. You get a curve like this. So this is f inverse of x and this is f of x. Part of the question is find an expression for f inverse of x. To find f inverse of x, write the given function as y is equal to 3 plus 2 sine 1 over 4 x. Now exchange the x and y variable. So we get x equal to 3 plus 2 sine 1 over 4 y. Now make y as the subject. So x minus 3 is equal to 2 sine 1 over 4 y. So sine 1 over 4 y is equal to x minus 3 divided by 2. 1 over 4 y is equal to sine inverse of x minus 3 divided by 2. So y is equal to 4 sine inverse of x minus 3 divided by 2. Now replace y by f inverse of x. So f inverse of x equal to 4 sine inverse of x minus 3 divided by 2. Next, C part of the question is, the diagram above shows part of the graph of the function g of x equal to 3 plus 2 sine 1 over 2x for negative 2 pi less than or equal to x less than or equal to 2 pi. Complete the sketch of the graph of g of x on the diagram above and hence explain whether the function g has an inverse. So first let's complete the graph g of x. Okay. When x equal to negative 1 over 2 pi, let's find out what is g of x is. When x equal to negative 1 over 2 pi, g of x is 2.23. So that will come approximately here. Minus pi. It will come here. When x equal to minus 3 over 2 pi, g of x will be this. Then when x equal to minus 2 pi, g of x will be equal to 1. So now we have completed the g of x. So hence explain whether the function g has an inverse. Yes, it has an inverse because it is a one-to-one function. How, how do we know that it is a one-to-one function? If you draw a line here for some value of x or here, it has to cut the curve at least at only one point. It should not cut more than one point. So if it cuts at only one point, then it is a one-to-one function. So this curve at all the point cuts at only one point. So this is a one-to function. So it has an inverse. Yes, the function g has an inverse because it is a one-to-one function. Next part of the question is describe fully a sequence of three transformations which can be combined to transform the graph of y is equal to sine x to the graph y is equal to f of x, making clear the order in which the transformations are applied. So y is equal to sine x to y is equal to 3 plus 2 sine 1 over 4x. So first start from here. First there is a stretching in the x direction with a stretching factor of 4. So next is 2. So this is a stretching along the y direction with a stretching factor of 2. Stretching along y direction with a stretching factor 2. Next, this 3, it's a translation in y direction with a vector, the translation vector 0, 3. Translation in y direction with vector 0, 3. The second term of a geometric progression is 16 and the sum to infinity is 100. Find the two possible values of the first term. The second term of a geometric progression is AR. So AR is equal to 16 and the sum to infinity, that is A divided by 1 minus R, equal to 100. First let's find out what is A here. It is 16 over R. Substitute that here. So 16 divided by R minus 1 minus R equal to 100. So 16 divided by R equal to 100 multiplied by 1 minus R. This can be written as 16 equal to 100 R multiplied by 1 minus R. So 16 is equal to 100 R minus 100 R square. So 100 R square minus 100 R plus 16 equal to 0. To factorize this one, first let's divide the whole term by 4. So 25r square minus 25r plus 4 is equal to 0. So 5r minus 4 multiplied by 5r minus 1 equal to 0. So 5r minus 4 equal to 0, or 5r minus 1 equal to 0. So r is equal to 4 divided by 5, or r is equal to 1 divided by 5. So when r is equal to 4 over 5, let's find out what is the value of a. A is 16 divided by r. (20). When r is equal to 1 over 5, a is equal to 16 divided by 1 over 5, which is equal to 80. So the possible first terms are 20 or 80. Next, B part of the question is show that the nth term of one of the two possible geometric progression is equal to 4 power n minus 2 multiplied by the nth term of the second geometric progression. Okay, so let's write the two different geometric progression. When a is equal to 80, r is equal to 1 over 5. So then the geometric progression will be un is equal to 80 multiplied by 1 over 5 the whole power n minus 1. This is equal to let's write the next geometric progression also, then we will simplify it. So E is equal to 20, R is equal to 4 over 5. The second geometric progression is un is equal to 20 multiplied by 4 over 5 the whole power n minus 1. This can be written as 20 multiplied by 4 power n minus 1 divided by 5 power n minus 1. And this can be written as 80 can be written as 20 multiplied by 4, and this is 1 over 5 power n minus 1. So we need to prove one geometric progression is equal to 4 power n minus 2 multiplied by the another geometric progression. So un is equal to 20 multiplied by 4 power n minus 1 divided by 5 power n minus 1. Let's substitute from geometric progression 1 that 20 divided by 5 power n minus 1 equal to un. Okay, so un equal to 20 divided by 5 n minus 1. So divide by 4. So 20 divided by 5 power n minus 1 is equal to un divided by 4. Let's substitute that here. So we will get un divided by 4 multiplied by 4 power n minus 1 as un. Un equal to small un multiplied by, when 4 goes to the numerator, the power will be negative 1. So 4 power n minus 2. The next part of the question is, the equation of a circle is x minus a the whole square plus y minus 3 the whole square, which is equal to 20. The line y is equal to 1 over 2x plus 6 is a tangent to the circle at the point P. Show that one possible value of a is 4. Find the other possible value. So equation of a circle is given and the equation of the line which is a tangent to the circle is given. So the line is a tangent, so it will touch at one point the circle. So at that point the circle and the line will be equal, the coordinate at that point. So we can write x minus a the whole square plus, for y, let's substitute the equation of the line. So 1 over 2x plus 6 minus 3 the whole square equal to 20. So let's write this, x minus a the whole square plus 1 over 2x plus 3 the whole square equal to 20. Let's expand the brackets. X square minus 2ax plus a square plus x square divided by 4 plus 3x plus 9 minus 20 equal to 0. Combine the x square terms. So 5 over 4 x square plus 3 minus 2a multiplied by x is the x term. Then the constant term a square minus 11 equal to 0. This is of the form x square, ax square plus bx plus c is equal to 0. It's a quadratic equation. So it's given the line is a tangent. So in this case, b square minus 4ac is equal to 0. It's a tangent. So b square minus 4ac equal to 0. So what is b square here? 3 minus 2a the whole square minus 4 multiplied by a is 5 over 4 and c is a square minus 11. This is equal to 0. Let's expand this one. So 9 minus 12a plus 4a square is 4 and 4 gets cancelled, minus 5a square plus 55 equal to 0. Now combine the a square term, negative a square negative 12a plus 64 equal to 0. Multiply the whole term by negative 1. So you get a square plus 12a plus 64 equal to 0. Let's factorize this one. A plus 16 multiplied by a minus 4 equal to 0. So a is equal to 4 comma negative 16. So a is equal to 4 is already given. So show that one possible value is 4 and find the other possible value. So the one value is 4, another value is negative 16. Next part of the question is, for a is equal to 4, find the equation of the normal to the circle at P. Suppose this is a circle and this is the tangent. Here it touches at point P. So here we need to find the equation of the normal. So this will be the normal. So we need to find equation of this. This is actually perpendicular. So to find the equation of the normal, first we need to know the gradient of the normal. To find the gradient of the normal, let's first find out the gradient of the tangent at the point P. So for that, first we need to find out the point coordinate of the point P. So to find the coordinate of the point P, we need to equate the circle equation and substitute the line equation in that. So finally we get this one. So let's use this expression. X minus a the whole square plus 1 over 2 x plus 6 minus 3 the whole square equal to 20. So on simplification, we get the expression 5 over 4 x square plus 3 minus 2, the 6 equation we have to write 3 minus a multiplied by x plus a square minus 11 equal to 0. So here we are going to take the value of a as 4. So 5 over 4 x square, 3 minus 8, so minus 5 x plus 16 minus 11, so which is equal to 5, equal to 0. To simplify this equation, divide all the term by 5 and multiply by 4. That is multiply by 4 over 5. So we get x square minus 4x plus 4 equal to 0, or this can be written as x minus 2 the whole square equal to 0, which gives x equal to 2. So we need to find the coordinate of the point P. So at that point x equal to 2, then y is 1 over 2x plus 6, which is equal to 7. So P is 2, 7. Okay. So now we have to find out the gradient at the point P. Okay, the equation of the tangent is given. The equation of the tangent is of x plus 6. So the gradient will be 1 over 2. So from this, gradient is 1 over 2. This is the gradient of the tangent. So the gradient of the normal will be negative 2. Now the equation of the normal is minus y1 is 7 equal to negative 2 multiplied by x minus 2. We can write this as y is equal to minus 2x plus 4 plus 7, which is 11. The next part of the question is, for a is equal to 4, find the equations of two tangents to the circle which are parallel to the normal found in B. So this is normal. So we need to find two tangents which are parallel to the normal. These two are the tangent to the circle, but these two are parallel to the normal. Because the two tangents are parallel to the normal, the gradient of the tangents will be negative 2. So the equation of the tangents will be of the form y is equal to negative 2x plus c. So the equation of the tangents, these two tangents are y is equal to minus 2x plus c. Now we need to find the c value. For each tangent, the c value will be different. Okay. So this is a tangent to the circle. So we can substitute this equation in the equation of the circle. So x minus 4, because a value is given as 4, the whole square, plus y is negative 2x plus c, minus c, the whole square, equal to 20. Let's expand this one. X square minus 8x plus 16 plus 4x square minus 4x multiplied by c minus 3 plus c minus 3 the whole square equal to 20. Combine the x square term, 5x square minus 4x c minus 3 plus 2 plus 16. Expand this also, that is c minus 3 the whole square, which is equal to c square minus 6c plus 9 minus 20 equal to 0. So 5x square minus, what is the x term? C minus 1. So 4c minus 4 plus c square minus 6c plus 5 is equal to 0. Because this is a tangent, we can write b square minus 4ac is equal to 0. So the b square value is 4c minus 4 the whole square minus 4 multiplied by 5 multiplied by c is c square minus 6c plus 5. This is equal to 0. Let's expand the brackets. 16c square minus 2 times 4 times 4, 32c plus 16 minus 4 multiplied by 5 is 20. So 20c square plus 20 multiplied by 6, 120. C 20 multiplied by 5 is 100, negative 100 equal to 0. 16c square minus 20c square is negative 4c square. Negative 32c plus 120c is plus 88c plus 16 minus 100, which is negative 84 equal to 0. Divide all the term by negative 4. So c square minus 22c plus 21 equal to 0. C minus 21, c minus 1 equal to 0. So c is equal to 1 comma 21. So the equation of two tangents are y is equal to negative 2x plus 1 and y is equal to negative 2x plus 21. The next question is find dy by dx. So dy by dx. Okay, before that let's write y equal to k multiplied by 4x plus 1 the whole power 1 over 2 minus x plus 5. So dy by dx equal to k multiplied by the power 1 over 2 multiplied by 4x plus 1, decrease the power by 1. So negative 1 over 2 multiplied by the coefficient of x, which is 4, negative 1. So this is equal to 2k divided by square root of 4x plus 1 minus 1. Find the x coordinate of the stationary point in terms of k. So stationary point. So dy by dx is 0. So 2k divided by square root of 4x plus 1 minus 1 equal to 0. 2k divided by square root of 4x plus 1 equal to 1, or 2k is equal to square root of 4x plus 1. So we need to find the x coordinate of the stationary point. So we need to find the x value. So make x as the subject. So this is 4k square equal to 4x plus 1, or 4x equal to 4k square minus 1, or x equal to 1 over 2 multiplied by 4k square minus 1. So this is 4. We can write x equal to k square minus 1 over 4. This is the x coordinate of the stationary point. The next part of the question is, given that k is equal to 10.5, find the equation of the normal to the curve at the point where the tangent to the curve makes an angle of tan inverse of 2 with the positive x-axis. With the positive x-axis, the tangent makes an angle. So this is, suppose this is a tangent, and here it makes tan inverse of 2. Okay. So that is, the angle is tan inverse of 2. So tan theta is nothing but theta equal to tan inverse of 2. That means tan theta equal to 2. Tan theta is nothing but opposite divided by the adjacent. I hope you remember, actually the tan theta represents the gradient of the line. Okay. That means tan theta is equal to y over x. Y over x is nothing but the gradient. So we know the gradient dy by dx is 2k divided by 4x plus 1 minus 1. So here k value is given as 10.5. So 2 multiplied by 10.5 divided by 4x plus 1 minus 1. This is equal to 2. Okay, because tan theta is equal to 2, which is nothing but the gradient. So 2 multiplied by 10.5 is 21. 21 divided by square root of 4x plus 1 equal to 3. Or we can write this as 21 equal to square root of 4x plus 1. This is divided by 3. We can write this as 4x plus 1 equal to 49. 4x equal to 48. So x equal to 48 over 4, which is 12. So we need to find the coordinate. So when x equal to 12, what is y? Y is equal to k, that is 10.5 multiplied by 4x plus 1 minus x. X value is 12 plus 5. square root of 49, which is 7. 10.5 multiplied by 7 is 73.5, minus 12 plus 5. This is equal to 66.5. So 12 comma 66.5. Equation of the normal. We need to find the equation of the normal. We know the gradient of the tangent is 2. So the gradient of normal is negative 1 over 2. So the equation of the normal is y minus 66.5 equal to negative 1 over 2 multiplied by x minus 12. So y is equal to negative x divided by 2 plus 6 plus 66.5. 2y equal to negative x plus 66.5 plus 6. That means 72.5 multiplied by 2. 145. We can write this as 2y plus x minus 145 equal to 0. This is the equation of normal.